Welcome to the third of the Spring 21 CT lecture series. So today, the subject of our lecture is building commissioning. Everything is connected. Presenter is Mr. Wesley Stanhope. Mr. Stanhope is founder and CEO of Building Evolution Corporations. He's got multiple credentials. They include CEM, he's a certified energy manager, EBCP, existing building commissioning professional, CCP, certified commissioning professional, and finally CPHC, certified passive house consultant. So Mr. Stanhope is responsible for developing and implementing Building Evolution's vision, mission, and philosophy. This is a task he is eminently qualified for, with over 15 years of leadership experience in the built environment on both sides of the Atlantic, working in USA, Ireland, and the UK with construction, facility conditions assessments, energy management, and commissioning projects. Mr. Stanhope has brought over 370 commercial and residential construction projects from proposal through design and completion. We are delighted and grateful for Mr. Stanhope taking the time to share with us his wealth of experience and knowledge. Please, a virtual welcome, Mr. Wesley Stanhope. Okay.
Hey, how you all doing today?
And
also we have here's my business partner, Ken Neuhauser, just joined in as well. So we're going to be going back and forth a little bit in this presentation. I've been in Ireland for about 17, 18 years. While I was there, I kissed that Blarney Stone twice, so I'm really good at talking. We planned this. It might take 3 or 4 hours. That's not an issue, is it? Okay, that's the first joke. Okay, so building commissioning. Some objectives we're going to be looking at here is what kind of issues we could resolve in pre-design before the building even gets constructed. Distinguish between the different types of commissioning that there are. Understand that building problems are typically HVAC and enclosure issues, not just one by itself, and that people in occupancy change, that buildings need to adapt for that change. So looking at the building life cycle, sometimes talking with clients is kind of hard to chart what are all these types of assessments and commissioning and stuff like that. So looking at the timeline, if you have an existing building, you might want to start with a performance assessment. That is taking a look at the building, figuring out where it is right now, and kind of asking, where does the building want to be when it grows up? From that, you would start with a basis of design. And we'll get into this in a little bit more detail, what these mean. The base of design is kind of like the roadmap of where the building is going to go and how it could get there. When the improvements start to be made, there's either retro commissioning. So if you think of a building that's existing, you would do retro commissioning on it. We'll get into this a little more with some explanation on it and some projects that we've been through. Also, commissioning is for a building that's new construction. And after that, we get into recommissioning and real-time commissioning. And we'll get into this in a little bit more detail, but the main point about this is that commissioning should be starting all the way back here at the basis of design and following the whole way through the rest of the actual building life cycle. Performance assessment is something that should be done beforehand if you're going into a renovation of a project. Now, let's see. Just want to start with a little thinking point. Okay, what is more efficient? This is one of my slides I like to use. And just think about this over. Everybody, you know what that vehicle is? Toyota Prius, built for being pretty efficient, right? Now, there's a F-350. It's actually my F-350. Which vehicle is more efficient? The obvious answer is going to be the Prius, but sometimes the obvious is not the answer that is in reality, because it depends. It depends on who's driving that vehicle. So if you look at the dash on the picture on the left-hand side, you'll see the regenerative braking on that Prius. And that was me driving through Cambridge maybe about 5, 6, 7 years ago. And the point about this is that I was able to get that vehicle down to about 5 miles per gallon for about 20 minutes straight. Now, I know Toyota went through this really good process of designing that car to be energy efficient, and then they built that car to be energy efficient. But then it depends on the operator of, how are you going to actually use that building? So lining those three up together is very important to actually make sure that the car and the building is going to be very efficient, because operation, how it's going to be used, and who is going to use it is very important. So question is, when does the actual commissioning start? Well, we don't wait for the actual occupancy. It's too late at that point. Commissioning is a quality control. So you want to ask, if you're looking at it as a quality control process, does a system operate as intended in the drawing? Or did you get what you asked for? Did you get what you paid for? Well, if it's quality control, then sometimes this is what you get. It's a horse race between different types of buildings and how the quality of how they're built. But maybe what you asked for, maybe what you asked for to the design team and what was put through on the design documents and the specifications, maybe it was the last place horse is what you really paid for and what you really asked for. The commissioning should be starting earlier on in the actual process to try to tease out from the owners, before you build a building, what do you want of this building? How do you want it to perform? Do you want to be that last place racehorse, or do you want to be in the middle or towards the front? We try to get our clients towards the front of that pack. Here's an example. This is a project that we were asked to come in after it was constructed. So the design is already sailed. We don't have the ability to change anything on it. And it's actually, this is a LEED building, and it was all electric. Had really good intentions. But the electricity bill was, Ken, do you remember off the top of your head what it was? Like 15, 16 grand or so per month?
Yeah, between
winter?
10 and 14 grand per month.
10 and 14 per month. And why was it costing that much per month? Well, they were preheating the actual building with an outdoor, with a air handling unit that was all electric. So instead of just tempering the actual air in the building, they were heating the building with an all-electric air handling unit to such a point that, all the VRF or heat pump systems you see littering the roof up there, they weren't even being used. It was too hot. Some of them were, a lot of them were turned off when we were there in the actual winter, and some people had their windows open because the space was too hot. So part of this is about the design, and then how it's being, it has no ability to control itself because it wasn't included within the design. But in this case here, the unfortunate thing was the owner got what they asked for, and they got what they paid for. But they should have asked for something different. So this is where we start to, myself and Ken look at is, well, what if we looked at it from not a quality control perspective, but what if commissioning is a quality assurance perspective? And we're going to step back before the design even starts and figure out what are the client's goals? What's the building owner's goals? How are they going to use this building? What do they really expect the performance is, and how do they measure it? And there's two important steps involved in this. One of them is the owner's project requirement, OPR. One of them is called the basis of design. And the OPR, that's where the client identifies how the building should work or function. And on the other side of that, you have the base of design. It's kind of like this pre-designed document that helps guide the design team through the performance objectives. That's how we look at it, through the performance objectives of the actual project. So transferring how the client expects the building to work, transferring in a way that the actual design team could actually put that to pen and paper. So to give it an example, OPR versus BOD, owner's project requirement versus basis of design. If the client said, I want a building, well, the design team might say, well, here's an enclosure type and a mechanical system. Lock and var boilers. I do like lock and var, I'm not putting them down, but lock and var boilers. You have natural gas system and a lot of glass. The client gets what they paid for. But if they start to narrow that down, that no, they want to be a multifamily building, so now you know the type, and it needs to be 5 stories. Well, now the basis of design could start to narrow in some of the details on the mechanical systems. Oh, it has to be apartments. What type of apartments? Now they have to deal with elevators and fire protection. But what if it narrowed down a little bit more? The owner wants to put solar. don't wait to the end to ask for solar, because then the roof might be covered with mechanical systems or other type of penthouses for stairwells that are in the wrong position. Start at the beginning. So now the actual design team can cater for that from the start of the actual project. Making changes early on is really cheap. Making changes after they start to be designed or constructed, it's really expensive. So this is a cost-effective way of improving the performance. What if they want to go to a high-performance building, such as, like, say, a passive house, or just have a high-performance enclosure mechanical system? Now you can start to narrow down in the base of design, what are the goals of the project? You know, if a client came halfway through design and said, well, now I want to go for a passive house, it makes a lot of changes to design. But if they could figure that out at the beginning, it makes the design process a whole lot smoother. The smoother we make it, the more likely it is that it's going to be able to be built to the client's goals. So if you can get the owner's project requirements, you know, teased out of them, and get it down to an effective way to communicate that to the design team for a basis design, it's off to a really good start. Okay, we're kind of done here, right? We figured out all the performance goals, and we figured out how to help out the design team. Well, not exactly yet. I'm gonna let Ken talk about this one. This is one of his design reviews.
Sure. So there may have been a goal defined, but then there's still the process, really an integrated design process of ensuring along the way that do these various details, do they actually follow the objectives stated and sometimes unstated of the owner, of the client. So here we had something as simple as a window detail. Well, simple, except it's a hole in the wall, and it's a big hole, and it repeats. So we need to get this detail right. So there's a lot that can be done often if we get in there early to improve the design and make sure that it stays on the rails towards the objectives. And I'm not going to read all those little comments, because that makes my head hurt just looking at them.
And one of the ways that's really good, Ken mentioned on about being an actual team effort, is that integrated team. Here's some examples of actually working with the actual design team, architects, engineers. You know, always good to have a whiteboard in the actual room. When there is a whiteboard, you usually see Ken still hovering around it, because he's got his marker out ready to do a detail for the enclosure system. But hammering out the details early on and having buy-in from the team really helps the building actually get to the performance objectives of the clients. So different types of commissioning. Well, we have commissioning of a new building. This is where we're going to go in and make sure that what was on the design is actually built and that it actually functions the way it's actually originally intended. On the picture on the left there, that's Liam. He's actually at the flow hood there checking out the CFM of diffusers. And in that case there, that project, it's supposed to be 200 CFM of air. Some of them he was registering about 7. And in part because of that was the actual contractor substituted the hard duct for flex duct for 60-foot runs. And that doesn't really work too well in air systems. But here's an example of a new project, new building, operating for about a year, that has a lot of issues. We weren't involved in the design phase of this project. And the client asked us to come in and take a look at this. Could you commission this building? It's still within warranty, a lot of comfort complaints, can't figure out what's going on. So we go in, take a look at 2 different units, and what we're told is that, get the annotation tool, the actual bedrooms here in the corner, 3 bedrooms, they are cold, colder than the rest of the unit, and they can't figure out why. Okay, so we go in, we're taking a look at the actual fan coil unit, FCU, and the ductwork that's supplying out the diffusers and returning back from the ceiling level. What we see in the drawing is that there's volumetric dampers. That's where you see the VDs. to adjust the actual airflow to each individual diffuser. But there's no ceiling hatches there. There's no place where you could get access to it to make an adjustment. So what are the odds that there's a volumetric damper installed? In this one here, we took some measurements, and what we found was that majority of the air is going to certain locations, but not to where it was wanted to go. So the client was actually up for doing some demo investigation. Some clients don't like to put holes in the building, but in this case here, stop the annotation, they were okay with it. So above, right behind where the fan quality was, they cut a hole in the actual ceiling to see where the ductwork is. And then they drilled a hole in the actual ductwork for us. I put the bore scope in to see what was going on inside that ductwork. What we're able to see was that, for starters, there's no turning vanes at the 90-degree turn of the ductwork, but also all the takeoffs that came off that central duct line was all flex duct. It was shown in the design as being hard duct. That changes the actual pressure on the system and could reduce the amount of airflow. But I also did not see any volumetric dampers, so there's no way of balancing the system. So going back to how the system in reality was working versus how it was shown in design, the majority of the air, I'm not changing, majority of the air was going to the living room and kitchen because it was the first takeoffs on that duct. There was no way of balancing it. The bedrooms are being starved for air. The other thing is that the thermostat is in the location where there's too much air supply from the fan coil unit. So the area that gets the most amount of heat out of the fan coil unit actually gets satisfied turning off the system so it shorts the cycles. The bedrooms never reach temperature. So it was small little things that they made changes to in the actual construction on this one that made a very big impact on how the actual systems operate and causing a lot of comfort complaints inside the actual unit. So that's where things are deleted or taken out of the design when it was in construction. What happens when the opposite happens? When things are added. In this case here, we're out in Chicago and looking at a boiler. That's me with the hat on, looking at the boiler, and it's just not working right. If anybody's ever seen, worked with boilers, they have a warm weather shutdown. When it gets to a certain temperature, the actual system will shut down, and then any temperature in between there is a linear scale of when the outdoor air temperatures, in this case here, is 55 degrees, the boiler would produce 130-degree water. And when the outdoor air temperature gets really cold, say 10 degrees in this case, the boiler would produce 108-degree water, produce more temperature, more heat to satisfy the building's need. At the day that we were there, it was 34 degrees outside. The boiler was telling us it's supposed to produce 153 degrees water. Not necessarily the case. It produced 130 degrees consistent every day of the week, no matter what temperature it was outside, whether it was 50, 60 degrees outside or whether it was 10 degrees outside. So we started scratching our head, talking with the controls contractor and the mechanical contractor and lock and wire rep about how is this thing being controlled. And they, after phone calls with the boiler rep, this made, he said, oh yeah, but there's this building automation system inside the actual room to control the pumps, and that's tied into the boilers. That was never part of the design, but they added in this Honeywell control system to control the differential pressure of the actual building loop pumps. But then they had that override the actual boiler control. So no matter what you did to the boiler, you could not change the actual settings. It would just continually run at the same temperature all season long. So they had to look at the actual controls and separate just the two little color blobs there, separate the boiler controls back out from the pump controls because of that added software and control features they added in. They thought would make the thing work better, had to be stripped back down to just controlling the pumps. and let both systems work together but independently. So adding that little bit of extra onto this building made a big impact on how comfortable the building could be and could even keep temperature for the residents during winter. I'll let Ken take this one here
Sure.
about the enclosure.
Right. So here in this example, we have a fluid applied air barrier. And Wes, you want to jump ahead to the next phase? Yeah. So why would the owner do this? What are they trying to achieve with a fluid applied air barrier? Now, I'm no genius here, but I would guess that if they went through the trouble of smearing Pookie all over gypsum sheathing, which is already kind of airtight, they must want this building to be really airtight. So they put this fluid applied stuff all over the building, all over the flashing of the windows. All right, that looks fairly continuous from the outside. But then there's another question. As you look inside the building or just around the corner, you see that they have a wonderful air barrier, but that doesn't give them an air barrier system. Because we can see in this area here, you can see what happens when we have this fuzzy mineral fiber, which is very air permeable, on the back side of that very sheathing that has that wonderful air barrier material on it. So we know that we have created air leakage path. We also know that there is really no practical way of controlling the airflow in these cavities. And just because of the vagaries of construction and tolerances, we know that these spaces are going to be connected throughout the building. So, well, one thing we could do is, with a project like this, I guess a quality control commissioning might be coming in at the end with some blower doors, and we can measure the air tightness of the building to see if it is air sealed. But really what would be more productive would be to look at the design and perhaps mock-ups in early construction to determine whether the building is air sealable. And that would really be the area of influence for the project. All right, let me get rid of that muck here. And here's another example. This is the, it's the way we usually do it versus the way it needs to be done. So here we have a typical mock-up on a new construction building. We're going to put a window in there, and the installer, oh yeah, we do this all the time. We'll do what we always do. But what they always do is tape the bottom flange of the window and put the window in the opening with just a little bit of, maybe if we're lucky, some flashing underneath. Well, what we really want in this project, we want to have a robust water control so that when the water window leaks, not if, because windows do, the water goes outside instead of inside the wall. So this was a process of working with the sub to go beyond their typical understanding of what they're going to do and make sure that they actually demonstrate an understanding of what's going on with the plan. And one thing that's really nifty here about the picture on the right, I want to share with you guys a building science party trick that you can do on just about any construction site. If you go there during cold weather and you see that they have the windows installed, and if you see that they've taped across the bottom of the window, here's this nifty trick. You can grab that tape and pull it off, and I'm willing to bet you $1 to Thursday that water's going to run out. Because if it's built in cold weather, there's going to be condensation. It's going to be stuck behind the flange, and it will demonstrate your point that window openings need to drain. Now, there's also a great thing, and part of this process with commissioning is working with the subcontractors, because this is not to have some know-it-all consultant run out there and tell builders that they're idiots, because in fact they're not. In fact, they have a lot of experience and useful insight. So over on the left, we were pretty insistent that we wanted a back dam so that if water is under the window, it goes outside and not inside. But in this current configuration here, the contractors, after years of hitting their fingers with hammers, are not going to be able to get their fingers under that window and manipulate the shims that are needed to get the window in the right position. So great. It's good that we worked this out in a mock-up and talked it out then, because what we do is we move that piece of wood back and we make sure the contractor orders an extra wide piece of flashing membrane. And that way we can get the system to work and have it be constructible at the same time. So it is very much an integrated process. It involves the design team and has to continue involving the construction team as well. We can move on, Wes.
Yep, I was waiting for the slide to react. So retro commission, that's commissioning, and that's where you're building something new or you're renovating something right now, and you're going to actually be able to impact that actual design and construction. What about retro commissioning? And that's where you have an existing building. It's built. And a lot of buildings I've been in have already been built. Isn't that right, Ken?
Just about every building I've been into has been an existing building.
There you go. So what we have here is an existing building. It's out of warranty. You don't have a design team to fall back on. There's no contractor coming back to fix something. This thing could be in here for 5, 10, 20 years. What happens? And this is where you have to kind of put on your thinking cap a lot more, because you have to diagnose what is the issue, why it's the issue, what are the ways for the client to get around it in their building. And this example here, there's 2 large Wiesmann boilers, and those boilers are in a central location in an old boiler plant. Well, the boiler plant's been renovated. Wait, hold on. And it's going out to 3 mill buildings that are now residential, now multifamily. So you got the old boiler plant now has these 2 Wiesmanns, and you have this building here, and it's going around to these buildings, right? So they're now being called south, east, and north building, 3 different loops. And the owner bought this building. These 2 boilers were installed probably about a year before they bought the building. They bought it probably about, this case now, 10 years ago. We were down there about 4 years ago to take a look at them. It wasn't able to maintain temperature in the north building for some reason. So we get down there, we start to actually investigate why. And one of the things we love doing is data, putting data loggers on things to figure out how things actually react. How do they respond? When are they on? When are they off? What temperatures and humidities and space conditions? How much electricity they use? All different types of data loggers. This one monitors on off. So we see the 2 boilers that we just saw in the picture. Boiler 1, I didn't color that with a black crayon. That is that boiler switching on and off, on and off, on and off, every about 3 minutes. So can you picture getting into your car, sitting in the driveway, and turning on your engine, turning it off 3 minutes later, turning it on, turning it off, and doing that every season from maybe September to June? It wouldn't last that long, and neither would these boilers that are much more expensive than most cars. So why is it doing this? Why is one boiler staying on for the entire season without shutting off, whereas this one here is just short cycling and really isn't producing much? When we started to take a look at how is this building actually configured, where I showed you the north building, the south building, there's 3 buildings altogether. Well, you have the north, the south, and the east. And the south building is the biggest building. And it was pulling off the majority of the heat. Okay, but it's the biggest building. And east building was the next to take off heat, and then the north building. And I started to scratch my head at this because the way it's piped, 2 pumps for the entire complex, these big old mill buildings that you see in a lot of New England towns. Here they are, 2 pumps. One is dead. The other one is actually pumping. Okay, so you're down to 1 pump with no redundancy. You're not going to run both at any one time anyways. But that pump was there to circulate water through all 3 buildings and circulate through the 2 boilers. No other pump in the facility. So I was like, there's a flow issue going on here. So he started to monitor the temperature between the supply and return of each building. And there was already previous, flow measurements for gallons per minute to each loop. And that somebody had tried to correct the issue by putting in a bypass to bypass some of the boilers because they knew that there was a flow issue already. But here, some of the things is we shouldn't do things halfway. We need to try to figure out not the symptom, but what the root problem is and correct for it. So, I just close this. So why does the B1 short cycle and why is the north building cold? We started looking at the data. And looking at this here, two of the buildings were actually okay on temperature. And that's that bigger south building, east building. But once you get to that north building, that's that green line. Do you see the way it's after shooting down about 10 degrees lower than the other building? Something is going on. It's because it's the third one. It's the third one in the actual loop. So the A building, the south building is taking off the majority of the heat, and then the water has to flow to the next building, and then the third before it gets back to the boiler plant. And that one boiler is short cycling. That boiler is short cycling because of the actual flow. It's not getting the actual manufacturer's recommendations through it for the amount of flow that's required. The other thing is, if you look at that north building that has the issue, it needs a lot of heat. It's not a mill building sitting on the ground. It's one that's sitting up in the air. So it actually has open air parking underneath it, exposed on all six sides to the city, and basically heating the city through leakage. It needed more thermal capacity from the boiler system. So what do we do on this one is we had the actual owners, put in the dedicated pumps for the actual boilers, so they had the correct amount of flow dedicated for each boiler. Put in an actual loop in the actual boiler room, so you had an actual system to circulate that boiler water around the actual boiler loop. And then have each building tie off its own pumping system. So it's kind of like a primary, secondary, tertiary for each building, and they could each control the flow through each building to ensure that they had the appropriate amount of heating. They haven't had any issues since. Before this, they had to actually put some of their occupants up in hotels when it got cold. Recommissioning is similar to retro commissioning or commissioning, but it's where you already have the building retro commissioned. You already have it commissioned the first time. Now you're going back there on a regular basis. It could be every year, every 4 years. Some states or federal government, agencies have it set that every 4 years you need to recommission the facility. You're doing a similar process, making sure the actual systems will function for their goals. Occupancy might change over time. Real-time commissioning is taking that recommissioning, but let's do it live. Let's watch the actual data, and whether you try to make changes every week or every month, but you're looking at the live data that you're getting off the facility. And you're able to respond, not waiting for a year or 4 years to make an impact. But when you start to see something actually change in the building, you can start to make an actual change in the settings or start to recommend a change to a piece of equipment.
And Wes, how often does that help you to actually identify something going wrong?
Looking at data?
Right.
There's data, looking at data like this is a really good way of finding issues with buildings. We've had ones where buildings we're drawing in ocean air through issues with their enclosure systems and mechanical systems. So it's two issues combined. But by looking at the data, we were able to pinpoint that the actual issues that are going on indoors was not the condition there. It was actually the outdoor air from the ocean that was being drawn in. One building, it was a case of getting an actual alert because the building loop temperature was going down too low. So it should have been maintaining 180 degrees. It was one of those nights in Springfield where it was like 7 or 8 years ago, and it was like 0 degrees outside. And the actual natural gas pressure regulator went in the building, so the boilers did not function anymore. They were just short cycling, turning on, going off on safety. And the building loop temperature went from 180 down to 90 degrees within about 2 hours. And I was able to alert the actual maintenance team as well to go out there and get the building online temporarily for the night so it wouldn't lose the building through breakages of the pipes, displacing of the tenants, and whatnot. Data is really important.
And I think another point you can take from this is that the commissioning is not just about saving energy or lowering operating costs from an operational perspective, because in your previous example, you mentioned that the owner was having to put people up in hotels because they couldn't maintain heat. That's a real expense. Who cares about the energy cost at that point? And also here, in this other example you gave where the boilers went offline, if you lose the system, burst pipes, that's a real damage to the building, and that's going to eclipse any amount of energy savings you can get by tweaking or reprogramming the boilers.
Correct.
So commissioning is really it's a safety net against risk management, not just about improving and optimizing performance.
A lot of other goals that are higher priority. And if you do it right, the energy efficiency comes along. But one of the things that we look at with clients is that we don't go into it just for energy savings. We're going in there to improve the indoor air quality, the durability, the performance of the systems on many other levels, and the energy efficiency comes along for the ride. Just not me driving the Prius. Okay, so here's a section where we're going to go through a few past projects, and we're going to just have you think about this. Is it HVAC or enclosure issues that are causing problems, or is it all connected? And here we have one. It was the failing pipework of a building. You can see the picture on the left. I'm holding a piece of pipe that had failed on a 10-story riser that's providing heating and cooling to a condo. And there's 24 risers. Now it's flaking off at rust on the outside of the pipe. And the horses picture on the right-hand side, that is about, I don't know if anybody watched horse racing, but when horses are racing down the track, they usually wear blinders so they can't see left and right. They're focused on their goal of getting to the finish line. And a lot of times with design teams, with contractors, with owners, even with commissioning agents, we see that finish line and we get the blinders on. But sometimes you got to stop, pause, and take those blinders off. And, you know, when you take the blinders off, you know, you might be able to see what's around you. Oh, okay, so it's not so technical right now. So,
Wes, is this a vacation photo again?
You know, it's one over here. This is over in Ireland, looking down towards Lahinch. If anybody's been out there. So if you take the blinders off, you can start to see some, you know, nice scenery. You get to see the bay down there, and it looks really nice. But if you actually take the blinders off, you get to see more. Or to clip some more. That was right behind me when I took that first picture. So sometimes you got to turn around and look at everything from all different perspectives in order to see the real view of what's going on. So to the failing pipework, what is going on with it? Well, starting to take a look at the building, there's a few things going on. So we have an enclosure issue with it. It's a 10-story, 9-10-story building, and the enclosure really doesn't have much in the way of insulation, and it's not air sealed. And you can see on the picture on the left, there are pipework, that's the supply, return, and condensate coming back down from the actual building. And there's 24 of these risers. They're stuffed with fiberglass at the bottom. Now, about a dozen of them are in an unconditioned underground garage, which has got louvers open to the outdoors, so it's really outdoor air. In the summertime, that's hot, moist air. And then the other half of them are out the front on an overhang, which also has insulation stuffed around them, so it allows the outdoor air directly into them. Two-pipe system. It does heating and cooling. So in the summertime, these pipes get really cold. You got warm, moist air because the enclosure is kind of poor. But that same system had a chiller, and the chiller was from the 60s. It just wouldn't give up on this chiller. So they asking us like, what's going on here? Part of it was the enclosure, but if you can read those dials, this is in a Brookline, so it's kind of got the Boston accent on it. Kinda good, very good, almost good, no good are the 4 compressors on that chiller. So how many decades have been operating with it? Kinda good or no good. And when we monitored this building, we did the supply, return, water, temperature coming off the chiller to the building. It was only able to operate in the 50s for chilled water. Now, when it gets that high, it can't really, by the time it gets up to the, around the building, it circulates and people are cooling, it's no longer dehumidifying either. So the indoors are high relative humidity. So that was another thing that's attacking the pipe work. So deferred maintenance, kicking that can down the road way too long, waiting to replace a system, really has caused a bit more issues with deteriorating the actual building infrastructure. This is another example of enclosure or mechanical, or is it both? This is one that I like to call River Runs Through It. I don't know if anybody's ever seen that movie. But in this one here, I was up taking a look at this complex mill buildings that have been converted over to multifamily. And when I walk in, let me get the annotation up, because when I walk in, I get to the elevator and I see like this Home Depot box of air fresheners. And the stairwell, there's air fresheners attached to the side of the stairs. And then the doors to the stairwell to the corridors are all propped open. Now, there's a reason. There's like a funky smell in the building. You're walking around, what is that? There's something going on here. And they're covering up with a lot of air fresheners. So, start taking a look around. And we were here because it was using up a lot of propane. So I go down to the actual mechanical room, which is on the lower level, looking at the actual boilers. And while I'm there taking a look at the boiler controls, which weren't set up, they were even operating at full capacity in the middle of July, which nobody would need heat. I saw this hatch in the actual floor. And I asked the maintenance person, where does that go to? And he says, oh, it goes to the dungeon. Oh, okay. So I waited for him to leave. Then I opened up the hatch to take a look at what was down there, as it was cold air rushing in. It's a mill building. So this building has gone through a design and renovation, had an assessment beforehand, and I don't think anybody ever opened this hatch. So I go down into the dungeon, and I can see that water is ponding up underneath it. That mill, where the water would go pass through underneath the building, grist mill, still has some water going through it. And if you look back up to the actual ceiling, to the floor above, it's leaky. You got old pipe work penetrations that aren't air sealed. You can see the steel beams are a little bit of the paintwork corroding off it, but in the bottom of the elevator shaft, somebody stuck some insulation up against the side of it, called it a day. That's not air sealing. So that's the bottom of the building. Well, the top didn't look too much better when you're up in the attic. You had a lot of insulation put down on the floor, but that's not going to do much good if air is passing right through it. And this is a wall to more apartments here on the top floor. There's nothing major there. Air was able to pass right through into the space. And Ken, would you consider this an air barrier? I'm gonna line you up
I would
now.
not.
So if you don't have an air barrier at the top, and you definitely don't have one at the bottom because it's open to the actual river, what's going on here? Well, did you ever see the stack effect? Where you can have, in wintertime, heating's on, you have negative pressure at the bottom of the building, sucking air in, and positive pressure at the top of the building, pushing the air out of the building, creating
It's a bit like a hot air balloon.
Yeah, just one with a lot of holes in it. So what if we looked back at this building here? What is really going on? Well, it's in heating season. and it's pulling air out from that dungeon and bringing it up to the underside of the building, up through the building because there's no air sealing inside there. And then we've seen the condition of the attic. They didn't change the insulation air barrier there as well. There's where it's not just a boiler control issue. Henry, you have it?
Yeah, I was going to say, even the pattern of the frost on the roof tells you that there's lots of air leakage through that attic insulation, because the frost is staying where the framing is, but it's melting between. So that tells me that there's a lot of heat leaking out of there through air leakage. So if air is leaking out, pretty good chance air is leaking in.
The building hasn't imploded yet?
It has not imploded as far as we know.
So one of the things I want to look at is that buildings actually, life changes. Buildings need to adapt to that. And that's part of what commissioning looks at, is not just what the actual system was designed for back in the day, but hey, we got an existing building. Does it work the way it was designed? But then does it work for what it's being used for now? Because I bet you a lot of people have been in buildings that have been repurposed over the years. And here's an example of one that hasn't. This is Holy Cross Abbey over in County Tipperary. It hasn't changed. It's been there for 900 years. It's still an abbey, working church. Materials are still the same. Yeah, sure, they probably had to replace the roof and do things like that because they did replace the roof on it, but it is still functioning for the same type of use, same materials, same occupancy since it was constructed. I know this building because that's where I was married, but it's still the same. Many buildings don't go through that type of a life and not have many changes to it. A lot of buildings will have a change or two for the good or the bad. The picture on the left is a school building that had been converted over to multifamily. And it's an adaptation, to make a reuse of the building. They are having a lot of issues with the actual comfort inside the building. And you talk about air leakage. In the old building, they would have had about 25-foot ceilings, 18, 25-foot ceilings, especially in gymnasium areas. They had higher ceilings. The windows, back from the original design of the school, to keep the students concentrating, the window sills were up high so that you couldn't get a view of the outdoors when you're in your class. So when they renovated the building, they built a new floor higher than the old floor. That way they bring the floor level up to where the windows are so that the apartments could actually get a view out of the building. But they added insulation on the exterior walls where the actual apartments were, but there's like this interstitial space between each floor where you can go crawling around. It's about 4.5, 5 feet tall. And you can see the old schoolwork inside there. You can see that the actual tables, the desks, the chairs, chalkboards cut in half horizontally across the actual wall, still left in place. Stairwells still opened up from top to bottom of the building, where the building was not sealed up well. So it's adapted, but it hasn't adapted very well. Picture on the right was a client back in Ireland asked me to take a look at that building, and I said, yep, that one's gone. It's been adapted too many times and not right, where there's a roof over a roof over a roof and roof tacked to the side of the building, and it was gone beyond the reasonable effort to actually fix that cottage. No longer resembled a traditional cottage anyways. So yeah, it adapted, but was it for a good cause or for a good goal? Here's an example of one that's actually adapting right now. This is a large-scale multifamily building. It used to be a mill, like many mills around New England. This building, kind of like we talked about the grist mill on the previous example. What are the odds there's water around it? Well, this one here, there is. There's water flowing right through it. That bottom right picture, Ken had the luxury of, they drained down that river. They dammed up that one section to allow inspections, and he was in there last week, I think, or 2 weeks ago.
Yeah,
Um,
that was
sounds like a
after they
fun time.
plugged up the dam.
Okay. So you have an old mill building that has been renovated decades ago to being a multifamily building, and now it's going through a substantial rehab. In this case here, this is where we step back and do the base of design. And the client had not actually gone through the design process yet. What do they want to do? Where do they want this building to be when it grows up? One of the things the client wants is they want this building to be comfortable, but they want it to be a high performance. And they have goals for that, and I'll get onto that. But do you see this window here where the transformer is? That's not the boiler room. Boiler room is below that, where the air intake is. That air intake is still above your head. Now remember, the river runs through that building. Those boilers, that boiler room, if it floods, get about 6 feet of water inside the boiler room. That's not very resilient for a design. So that was one of the things we're looking with the client about the base design of this building was like timeout. Nobody wants to go, and they actually couldn't for insurance reasons, put a boiler room back into that actual location. Because if it floods, you have to hotel all these families. Well, what do we do? If you're going to spend money to renovate the actual building and replace the actual systems, that's your least cost opportunity to do something right. But Mike, see here, we got some new boilers. Well, things had to adapt while it's adapting because it couldn't keep up with heating. You have the 3 domestic hot water boilers on the left-hand side. They asked me to go down there a few months ago. It can't keep up for heating, space temperature, and it can't keep up for domestic hot water. Well, these are multi-therms. They got 3 boilers attached together, so it's modular, and there's multiple sets of these. But if you see here, that one's missing. This one, they had to keep on fixing because it broke. This one's operating. So they added in a temporary, like a couple of years ago, they added a temporary domestic hot water heater to the right. But they never took out the heat exchanger that's above these, that actually, these systems go to a heat exchanger. Heat is extracted out of that to go to the building loop for heating and to go to domestic hot water. So it's already being robbed for the heating loop before it went for domestic hot water. But because only 1 out of 3 was actually working, it was actually not really satisfying the heating loop as well. So on a temporary basis, this building has adapted by adding in an armor boiler and then another lock-and bar for space heating. So you have 2 boilers here to do to boost up the temperatures, make sure the building's actually able to withstand the next year or 2. Remember, I'm standing inside here. This is the floodplain. I'm drawing this line here. I went in there and had to measure where the floodplain is and what electrics, controls, and boiler heating systems and pumps are below that floodplain. The exhaust isn't. Everything else is basically below the floodplain, so it's not a good situation. But what are they actually doing there? They got to replace all these. Well, what they're doing is they're electrifying the building. But the client would, they do a lot of VRF, variable refrigerant flow systems, and that is common these days, especially in new buildings. This is an old building. Doesn't have the best enclosure. The other goal that the client wanted to have was to reduce the amount of refrigerant that goes through the building. Doesn't want to add to the refrigerant issues with global warming, and wanted to try to find a system that would have reduced refrigerant, but also with a VRF system, the air temperature coming off the fan coil unit might only be about 115 degrees or so. Well, in an old mill building with limited insulation, that might not work that well. The occupants might be uncomfortable. So we did some research and worked with Mitsubishi on this one, where we still have the outdoor VRF equipment, the same that you would have in a typical VRF system. And you still have the branch controllers, similar to what you have in a typical VRF system. But here's where it starts to get different. This is called HEX. It's a heat exchanger. I don't know, they didn't come up with a different name for it, but they call it HEX. It's simple anyways. And what it does is the refrigerant goes from outdoor unit to branch controller. Branch controller could be linked to 1, 2, 5, 10, depends on the size of the system. Multiple hex units. This then is hydronic. It's water, 2-pipe pumped, just like a lot of mechanical plumbers have installed for decades. That goes out to an actual Whalen or other brand fan coil unit. That is going to condition the space. But what's different about this type of a system is that this hex here, we might have like say 5 or 6 of them off of one of the outdoor units, but the last unit is called a hex booster. It has another compressor built inside here so that it's able to compress the refrigerant and actually bring it up the water up to an even higher temperature. It's able to boost the system. So with this system, it was able to bring the water temperature for the fan coil units up to about 160 degrees. And by doing that, it gets over the issue of, well, what happens with a refrigerant-based system in an old mill building that doesn't have the best enclosure? And it also gets over, well, we don't want to run refrigerant piping throughout the entire building and have issues with, leaks and having to refill it over the time. I know good contractors will get it in with having limited leaks and stuff like that, but things do happen. Buildings age. We wouldn't be in business if there was never an issue in a building. A lot of people wouldn't be. So with this, it ends up getting the building. This is not the building. Next picture I'm going to bring up, but it's a same system in another building. It's actually a fire department where you have the hex boxes, and they are 2-pipe water, hydronic. There's like your Takeo pump pumping out to the actual building, out to your fan coil units. That might be going out to, say, in our case, this would be attached to about 4 apartments. And maybe about 5 or 6 of these would go to one of those outdoor VRF equipment. Here's your branch controller, similar to what you'd have in a typical VRF installation. But now it's after getting over a lot of the concerns they had, but how do you retrofit this? I think it looks pretty neat. On top of that, I'd be proud if that was my mechanical room.
So you took a situation here where they had a problem that needed to be solved of boiler room below the floodplain, and
Yes.
took a problem as an opportunity to move to the next level of where the building wants to be and where the owner wants the building to be.
Yes. Sometimes don't look at them as problems, look at them as opportunities, as Ken was saying. Because if the owner if you have a boiler or air handling unit or other piece of equipment that needs to be replaced anyways because it's end of life, because it has issue, in this case it's special, it was end of life and below floodplain, well, it needs a lot of investment to get it up and move that same type of equipment to a different location. Put that money towards doing something better. The delta to actually make it really good might not be all that much. This case here, I think, was actually less. A little bit. It's being worked out now. So I wanted to, can't believe we're actually getting close on time. Here's that cover image. If anybody remembers that from an hour ago. Okay, so some things are connected. In this case here, that's wrong. Okay, so.
Wait a minute, is that an amp clamp?
It's an amp clamp on the domestic hot water piping. Can anybody see what's that little reading on that? That's over the milliamp running through there. You have electricity flowing through the actual domestic hot water piping in this building. So to back up on this, this is over a 20-story building that the actual pipe work failed a whole lot, top to bottom, on domestic hot water, and they replaced it back around 5 or 6 years ago. It's starting to fail again. There's pictures of the new pipe work that was just installed.
Oh. That doesn't look very good.
No. So we went in there to take a look at this, and we also had an electrician to come in with us to take measurements on it, because one of the things we did was we stood back and took those blinders off, right? I asked the clients, what is every project you've done here for the last 25, 30 years before this problem, the first time around when your piping started to go? And we started to do a timeline of all this. And then you look at the timeline, you figure out cogen's installed. Shortly after, pipe work starts to deteriorate. A couple years later, pipe work is replaced, and then starts to go again. Now, Ken, you were walking around with John, our electrician. You want to talk about what he found there?
Oh, well, we found that there was current going through the ground and ground connected to the pipes. And we found 5 amps of current going through the ground, which is, that's probably enough to really put somebody in a bad way. And certainly,
like 10
as
times the amount.
seen here, it's enough to cause a lot of corrosion on pipes. So if you go to this building, don't drink out of the water hose. You don't want to be the ground.
So some things are not supposed to be connected, but the issues are. So I think we try to keep that right on time.
All right, good job. Yeah, I think you hit it pretty much on the money. So I think Kath has a bunch of questions.
I do. Thank you. Yeah, I'll just start right from the top. And thank you, Wes and Ken. That was a really interesting presentation. All right, how does value engineering typically impact your commissioning work? Does it typically have a negative or a positive impact on commissioning?
Boy,
Does it lead to better or worse solutions?
The snarky answer is it's good for business.
Right.
I usually call it devalue engineering. It really depends on what's going on with it. We have times we're on design team meetings and the ERV itself will just get axed out of the actual design and go straight to outdoor air being brought in conditions because it saves X amount of money out of the actual construction. But then the actual operational costs would have paid for that within the first couple of years. And this is a building that's not going to go through another renovation in 25, 30 years. So there are times like we work with the actual design team, and what's really good is having the contractor on board at the beginning, having pre-construction contractors, where we can that's where it can work, where maybe there's better ways of actually constructing something. Maybe there's another better way of laying out the pipe work that makes it easier to build. And that's a way to make it more cost effective. That's like what I'm actually working on now for a project out in the Cape. Ken as well. We do that a lot.
Kath, I
Not
want to
necessarily cutting things out.
ask a question.
Sure.
So over the past 50, these projects that you show today, which are really poster childs for problematic situations, how many of those are recent, and are these culled from a collection of worst case scenarios that are really impressive to see and really illustrate your points? But are you noticing a change as you some 15 years ago? So you started around the early part of the 21st century to where you are now. So what's the change been?
A lot of the projects that we've shown here, majority of them are within the past couple of years, and some of them are actually active now. Sometimes we'll hold off on a new project just to protect the names of the innocents. You don't want to have a client or somebody see the actual the information right away. Some clients are on board with, yeah, if you find stuff, you present on it. That's fine. It's all part of the learning curve. What was the other part of your question then?
Well, I'm just curious if we're on a positive curve here. You know, there's certainly more information about improving buildings from a performance standpoint and for a comfort standpoint. So I think that, you know, that helps your business. But remedying these can be a pretty discouraging task when they're actually revealed on what the solution is going to be. I'm really interested. So I'm interested in how often your services, the advice that your service gives is actually applied.
With our clients, I would say majority of the time.
That's
There are
good.
times where, yeah, things do get value engineered out.
Yeah. Well,
Budgets just can't afford things.
Yeah.
Clients we work with, we kind of call it as like institutional clients, not
Yeah.
necessarily, you know, institutions as a historical sense, but somebody who's going to own and operate their buildings for the next 20, 30 years. One of our clients has outlook for like 70 years on their buildings. So they're going to feel the pain if things are done wrong.
Yeah.
What they usually will look at is how do we get it done right the first time around, or at least the second time around. It comes around again usually, but
Yeah. Well, that's good to hear. Go ahead, Kath.
Okay, so who ideally hires you, the commissioning agent? Should it be the general contractor or the owner?
it's the owner. Usually
The
we're
owner.
working through, you know, third party trusted advisor for the actual owner.
And do
There are
you,
times where we do work for the architect or design team as well, every once in a while, because they want to have the added quality control and quality assurance on their design and construction, but 95% of the time it's with the owner.
are you always hired to work on both the mechanical systems and the envelope? Or are you sometimes hired to look at one versus the other?
There are times where we're looking at just one. So like there's a new project starting up in Beverly where we're probably just gonna be looking at the mechanical systems,
Mhm.
but we might, if we see a few issues along the way, you know, we'll, you know, let the owners know, but it won't be part of our scope to actually work on that aspect. And there are projects where Ken does the enclosure aspects. He has, again, if you want to speak to the enclosure projects that you're working on, that's just enclosure, but we have projects that are just enclosure, not mechanical. But we try to be both.
Right, right. We can understand how both is the best. So deferred maintenance is a big problem in buildings, and maintenance can be expensive. How can you encourage owners to use your services? Do you start conversations with a cost benefit analysis?
Deferred maintenance, yeah. So one of the things that we've done before is and we still do, is we do facility conditions assessments, but we do as performance-based facility condition assessments. You know, what is the baseline of the building today? You know, how much is the building worth, brick and mortar? Not is the building worth, you know, in Worcester versus New York City, because that's location. But how much is the bricks and mortar actually worth? And then, you know, what are the conditions? And BOMA and other, you know, BOMA has like a guidelines for how long different building materials last, but then maintenance has a big, you know, impact on that. Like that boiler I showed that we're short cycling every 3 minutes. I don't care who says if that thing's gonna last 20 years. If that's operating like that, it might last 5. So you got to take your own experience into that equation and help build like a financial roadmap. You know, a lot of people drive cars. You get that O&M manual that tells you every 5,000 miles to replace the oil, do an oil change, and then at 60,000 miles, do a timing belt. Buildings don't have that. So we look at it as like, you know, doing the facility condition assessment is what are those, you know, O&M manual roadmaps for a building that needs to have replacements based on age or maintenance, how much it's going to cost. And, you know, when you go to do that, let's shift it to something different. You know, air handling unit, let's go to an ERV. So you can make those opportunities versus problems.
And Kath, another way that we try to address this is always a conundrum, right? Deferred maintenance, because it's hard to, it's a bit like insurance. You know, how would you convince somebody to pay for insurance when they don't know that there's going to be a disaster, right? Like, would we get flood insurance on top of a mountain? And I think people in a floodplain probably understand that they need it. And so with a building, it's maybe somewhere in between. So understanding not just the easily perceived, energy efficiency, is pretty easy to quantify, but the what's the cost of a burst pipe? Depends. Does it happen during finals? Does it happen during parents' weekend? You know, it's it's difficult to quantify, but I think the important thing there is that the real driver ought to be risk management. Optimal performance is great, but avoiding disasters is essential.
Yeah, that makes sense.
Yeah, Kath, I have a question perhaps for Ken. So with building enclosures, have you noticed over the last several years that there is an increased knowledge base in the contractors and subcontractors and technicians that you're working with out there, that they understand to whatever degree they can the building physics that are actually behind the methodologies they're going to use to put whatever you're specifying in place? Are we getting some improvement in that, or do you find that time and time again you're still having to in 2021 do a lot of educating?
Well, I don't mean to sound discouraging, but yeah, there's a lot of educating left to do. I will say a positive thing to that, Carl, is that at least we see design teams are aware that there is physics now, whereas we had to convince people that there was physics involved, and we need to respect the laws of nature, even more so than code, because they determine whether a building works or not. So yes, I think there is a slow evolution going on. I would say that I have found builders more aware, because generally they're the ones who are getting blamed, right? If a building doesn't work. So they are getting up to speed and understanding about air control in buildings, continuity of air and water control, proper flashing. So that is going pretty well. I think the design community is getting there. Like I said, there's an awareness among the design community that they need to be careful. But we were on a call just before this where the designers were asking about doing a dew point analysis. Well, you could do a dew point analysis, or if you knew how to read a psychrometric chart, we don't need an analysis. It's pretty obvious what needs to be done. So I think getting people beyond the fear of the building physics would be really helpful, so that they're not so scared by it and comfortable taking that on themselves.
Good answer. I like hearing about the psychrometric chart too. Good way to close it out.
Ken's got a shirt about the psychrometric chart.
Most days I'm wearing it, but
yeah, well, I think that
just in case it needs reference.
No one can ever have too many psychrometric charts.
Oh, there you are. Man after my own heart.
So I know it's 5:15, but can I ask one more question? Because it's a really good one.
Okay.
Sure.
Okay. So with the commissioning examples you presented, what happened when your clients found out about mechanical systems not properly installed, et cetera? Did lawyers get involved? Who paid for it? So essentially, how do these problems get fixed?
Every once in a while, and we try not to go down that road, a lawyer would get involved, but I would say that might be one every 18 months to 2 years. It's not that often, because sometimes the cost of going down that road of getting lawyers, getting everything, it outweighs the cost of just fixing the problem. If everybody works together, or even the client takes care of it sometimes. For example, I got a project right now that's not even occupied yet, and similar idea where there was some issues in design and some issues in construction. But they're just taking care of it now that we found out what the issues were, because it's not worthwhile fighting over it. with the ones that we show in the actual examples, just take a look. But they actually would take them on board, those ones, to get them fixed. Like the one where I showed you the pipe work that had the issues, that 10-story building. Well, that chiller is gone. That was cut up during the pandemic, actually. A really good contractor in Boston area took care of that. I got an engineer in to design that, and they cut that chiller up, replaced it with a new multi-stack modular system. So it's more efficient and able to maintain water temperature. The building owner right now, we're just finishing off at the reviews design for replacing all of those risers that you see that were brittle and falling apart in my hands. They're taking care of those issues right now. Don't know why it got that long to being deferred maintenance. I mean, who do you want to point the finger at? I'm not too sure, but they're just, band together and get it done. New construction, it's easier because if this contractor's still on board, they're bound to fix it because they're supposed to have it as per the drawing. It's when you find something where it's not as per the drawing, or it is as per the drawing, but the drawing has got an issue with it. That's where it gets a little bit fuzzy. But usually you can work it out.
All right, well, we're gonna close it up for some students now. Witching hours here. So in closing, I'd like to thank both Wes and Ken for a great presentation. And I'll alert the both of them for the arrival in the mail of the coveted VCT water bottle as a token of thanks. So you can have that to look forward to. And for everybody else, I alert you to the fourth and final VCT lecture of spring 21, which will be on sustainable construction and financial methodologies, presented by Bill McClay, principal of McClay Architects. So anybody can hang around if Wes and Ken will entertain a few more questions. And for the rest of you, thank you and good evening.
Thanks.
Thank you, Carl.
Sure, we'll see who stays if you have some other questions. How much blower door work you seeing on these bigger buildings now?
Probably, certainly more than we used to.
Yeah.
Yeah, I was directly involved in that around the turn of the century, getting out to buildings with, I think the record I had was 20 blower doors.
Yeah, that was my question going to be if you were using multiple setups, or if you got one of those big blower door trucks.
Multiple setups to even the pressure differences around the building.
Yeah.
Multiple blower doors, lots of radios and running shoes.
Yeah. Yeah.
There's an area that's gotten a lot easier, a lot better with we can just wire all these things together, set up a wireless network and control it from one laptop.
Yeah, that certainly has gotten better. Yeah, one of the things that was really struck me, some of the things that you see, like that first example in that, I guess it was apartment, that 2-bedroom apartment there they had all sorts of things wrong. You were diplomatic enough or cynical or sarcastic enough to call them little things, but volume damper's not there, one thermostat off in the hinterlands.
It's an example of VE, right?
Yeah, flex ducts instead of solid ducts. There's no directional controls at the 90s. Yeah, yikes. What do you think's driving that? Is all economics driving that back in the beginning? Like, hey, let's close this up and get out of here? Or do you think that it's actually ignorance?
So the start of it was they chose a fan coil unit that was economically driven. They went to a cheap type of a system that makes a lot of noise. So now part of it is asking, well, how do we make it quieter? Well, by changing it or making it a return duct. Either way, it's going to cost a lot of money to do that. When the actual construction went through, was it quality control? Was it someone just missed that? Someone just said, well, we're within 6 feet. We could make this work for code, or, within the 14 feet that's allowed for flex ducts. But when you start to add it up, that these things only could go so far on the pressure, and the fire department going by right now. If it goes so far into pressure on these fan coil units, they're not that strong. And when you start to add flex duct after flex duct after, there's so many of them that are taking off, it just might not work right the way it was designed.
Well, it's a lot of fun to see the disasters, I gotta tell you.
Well, we have this saying, right, Wes, that our success is really founded on failure.
Yeah.
This is how we learn, and this is how we move forward. I think as a species, not just as a practice.
Well, we really appreciate you